Hello and welcome officially to this webinar presented by Deakin University Alumni Engagement in collaboration with Deakin's School of Architecture and Built Environment. This webinar is titled Prefab 21, The Future of Affordable Housing. Sam Johnston here from the Deakin Alumni Engagement team. It's great to have you with us. I'd like to start by acknowledging the traditional owners of the lands from where I'm broadcasting today, the Wadwarung people of the Kulin Nations, and to pay my respect to their elders past, present and emerging. In this webinar, we'll be joined by representatives from Deakin's School of Architecture and Built Environment, building technology company FormFlow, and charity organisation Samaritan House to discuss a groundbreaking collaborative project that used prefabrication technologies to create a prototype tiny home. The result was a comfortable, affordable, six-star energy rated dwelling, suggesting that next generation design and manufacturing could offer a new way of thinking about 21st century housing. Our presentation will run for about 40 minutes, followed by a Q&A session with our presenters. Throughout the presentation, if you have any questions, please type them into the Q&A box and submit, and we'll get to as many as possible during the discussion at the end. Before I hand over to our webinar host, Professor James Döffler, I'd like to run a quick poll and get an idea of who we have in the audience and why you've chosen to join us for this webinar. Please submit your answers to the questions that will pop up on your screen in a moment. So that poll's up on the screen now. If you could please answer that, I'll give you a little while to do that, and then I'll share the results with everyone so you can see. Great to see so many people joining us. For those of you just joining, please do answer the questions on your screen at the moment in the poll, and it'll give us a good idea of who we have in the audience. So I'm going to give you just another few seconds and I'll end the poll, all right? And closing it now. And I'll just share the results with everyone. So as you can see on your screen, we have a pretty large percentage of Deakin graduates, so our alumni joining. Thank you for joining us. We have some students, staff members, representatives from the organisations joining us for this webinar as well. It's wonderful to have you all with us. Great, thank you very much. All right. So now I'd like to introduce the host of this webinar, Professor James Döffler, who will give you an overview of the project and introduce our other panel members as well. Professor Döffler is the Chair in Architecture in the School of Architecture and Built Environment at Deakin University. He has held positions at universities in the US and Australia as an academic and administrator. During his career, James has updated curricula for architecture programs with an awareness of international contemporary practice. He has led many research projects with industry partners on a number of topics, including facade design and technology, high performance building, prefabricated building systems, and sustainable water projects. These programs and projects have built on the strengths of creating collaborative, innovative, and sustainable learning and research opportunities. Over to you, James.
Thank you, Sam. Good morning, everyone. We're very pleased to have the opportunity to present our project to you in this webinar today. A presentation similar to this was intended to be done during Geelong Design Week back in March and was postponed due to the pandemic. So thank you for being with us now. This project began after a conversation with Matt Dingle from FormFlow about working with architecture to further explore what is possible using their unique technology. That brainstorming session led us to forming a design project that would involve students creating a prefabricated house using FormFlow technology. We agreed it would be amazing to have students design and build something that can be exhibited at Geelong Design Week in March 2020. As the project developed, conversations began with Samaritan House, who had a need to get a design for an independent living unit and a master plan for a microvillage at their site out in suburban Geelong. This was intended to be a transitional housing for homeless men, which was a unique project that we don't believe has been done in Australia previously. Next slide, please, Sam. We developed goals for the project that were introduced to Samaritan House and their facility here, as you see in the site plan. And generally speaking, we had some goals for the students to do research, synthesize knowledge, learn to work with builders, and basically create an emulation of professional practice for the students, so that essentially we would have a builder on board, a client, and then we would guide the students through the design process. So if you'll note here, we have divided it up into weeks 1 through 5, where essentially the students were doing research, design, and integration of all this information. And then weeks 5 through 11, they would continue to develop the design and create construction and presentation documents. Students were introduced to a brief history of prefabrication, and were also brought our builder FormFlow participated in these early weeks as well. After about week 3, the client, Brian from Samaritan House, came on board, and we began to develop the project around those constraints. Next slide, please. So this project then developed around really a schedule. So as you can see through the next few slides, we'll have the students working on various things in these various weeks. In week 3, we had our first pin-up where each student presented different design concepts, and that created a lively conversation amongst ourselves and our client. Next slide, please. In week 4, we went to visit Samaritan House and to the FormFlow factory at Menu Futures, and FormFlow gave us a wonderful tour of their facility and described how they actually create the FormFlow bend, and how they had a desire to create prefabricated housing. Next slide, please. So our students were there, they were taking notes, they were asking questions. As you can see here, Matt and his team were helping all the students understand the construction techniques that they had. Next slide, please. And then in week 5, we further developed the designs to show to the entire client body and a broader group of people that included Richard's home group. We had various representatives of Sustainable Geelong and a few other agencies there, and provided the students with an incredible amount of feedback in a very short period of time. This week 5 was a very important review because at this point we decided the attributes of the design that was needed to move forward. So Brian gave us a lot of guidance on that, and we began then to narrow down the strategies to develop the design in the following weeks. Next slide, please. So in weeks 6 through 8, we talked about these being design development weeks. We had a weekly meeting that lasted for 3 or 4 hours to make decisions and move the design forward. Students brought their design information to the table. We divided up into various teams, some teams being involved in the master plan strategy, other teams being involved in the house itself. Next slide, please. And then weeks 9 through 11, we began to develop the construction documentation and detailing. We did this at FormFlow's office in Manu Futures. Next slide, please. And this, working closely with them, we developed all the detailing, the dimensional strategies around the structural framing for the building, and then further developed all the window, door, and supporting details that were needed to create the documentation. Next slide, please. The structural frame for the first module arrived in the factory in week 11. A number of our students were there to see it arrive. We talked about the various issues that we had with dimensioning around the structural frame. And then next slide, please. And then over the following weeks, the construction of the individual models and the overall unit progressed. A small core of students were still involved even though their class time had ended, and were very interested in seeing this construction occur firsthand. Next slide, please. So in week 16, we completed the first unit, which was a major milestone. You can see here some finishing touches going in on the right-hand image, and then an image of the completed unit. Week 16 was the critical week to be done so that this unit could be installed during Geelong Design Week, which unfortunately was postponed due to the pandemic. Next slide, please. In those last few weeks, the students were also working on communicating this project to the broader audience, with, again, the intent being of exhibiting it during Geelong Design Week. The students created a number of posters that were meant to explain the design, the different strategies that were involved, sustainable aspects, and construction strategies. So through these series of posters, they were meant to communicate their ideas to that broader audience that might have come visit the house during Geelong Design Week. Next slide, please. So the right-hand slide shows the assembly diagram. Each unit was basically made up of 4 modules. The 4 modules would each get brought to the site. 6 modules, including the roof modules. Each module will get brought to the site and put together as a whole and to form the unit. Next slide, please. And we also had a parallel group of students working on the master plan to create a strategy for the 7 units that were required at the Samaritan House site. And another group of students that talked about the various sustainable aspects of the house, where we involved rainwater harvesting, connecting into the microgrid that's at Samaritan House with supplementary energy for their solar systems. Next slide, please. And it also involved an analysis of the energy usage of the house around those strategies. We also saw this as a snapshot of this particular house at this particular time. So we used this opportunity to explore the sustainable aspects of the materials in the house, and then begin to make suggestions about what next generation of these types of houses would include to actually increase the sustainable aspects of the various materials that were used. Next slide, please. So the outcomes of the project were extremely amazing for the students involved. The students essentially had an immersive experience in a real world project where we were emulating a professional office with a real client and a real builder that was involved in all the negotiation and collaboration that was necessary to build these prefabricated units. The students also learned various things about prefabricated building, sustainable technology and materials, the social and economic issues related to homelessness, and the transitional support that was inherent in creating this independent living unit. So it was an immersive experience in a professional making culture that we introduced to the students through this project. The project did meet its goals of being designed in time for Geelong Design Week installation, and we see this as a very successful example of industry and academic collaborative research partnerships. Next slide, please. We're very grateful to our sponsors, obviously our partners in FormFlow and Samaritan House, and all the other suppliers that contributed various aspects to the house to make this project possible. Next slide, please. And unfortunately, even though we weren't able to exhibit it at Geelong Design Week, we did have a mini event where we had a photo shoot on the day that we were supposed to install in Geelong Design Week, and that is this image here. Next slide. So I'd like to thank all the students and all the advisors that were involved in this project over the course of time. We had a lot of people also that aren't on this list that contributed, but I want to thank everyone for creating a very successful project and creating an amazing collaborative experience for our students. Next slide, please. Our next speaker today is Dr. Matt Dingle, who has worked as lead engineer at Ford's product development facility in Geelong during the 1990s and completed his PhD at Deakin University in collaboration with Ford stamping operations in 2001. He has lectured at Deakin University before founding his own company, Applied Research and Development, specializing in engineering design services. Matt subsequently co-founded Carbon Revolution in 2007 and was managing director until 2012 and head of technology development until 2013. From 2014 to 2017, Matt was director of technology at Sykes Racing. He's co-founder of FormFlow in 2016 and has been managing director ever since. His primary passion is bringing great ideas to life. Matt, thank you for coming, and please take it away.
Thanks very much, James. I'd like to reiterate what James said before. This has been an amazing project. Having been involved with Deakin for a long time and involved in collaborative research in a number of different fields, I guess, this has been a pretty unique experience as on all sides, I think, to be able to pull this together in such a short space of time and get such a sort of productive collaboration going between the three major partners. I'm going to give you a bit of an overview about FormFlow. I think James has already given quite a lot of background about the project. Oh, having trouble with the slides already. Here we go. So FormFlow is basically a technology development company. We were established in 2016, so we've been going for nearly 4 years now. The intention with establishing the company was to commercialise the technology that we'd developed. Since then, we've expanded fairly rapidly. So we've recently just moved out of our first premises, which was at Manufutures, which is where all those images were taken from. And we've just moved into a larger facility in North Shore to continue the production of Samaritan House units and also to scale up manufacturing of other prefabricated building systems that we've subsequently developed. We've also just recently began an agreement with BlueScope Steel. So we're licensing our first technology to BlueScope Steel. We have a really capable team with very strong links to Deakin University. So we've just recently taken on 2 new Deakin graduates, one of whom is an architecture and construction management soon to be graduate, and the other one's an engineering graduate. I've done my undergraduate, postgraduate, and some teaching at Deakin. And one of the other co-founders, Matthias, is still the head of one of the research groups at Deakin. Effectively, we're very heavily developing intellectual property. So we have a portfolio of ideas which is continuing to develop over time, and that's really the underpinnings of the business, if you like. And I already mentioned about the technology deal with BlueScope, but we're also looking at expanding that licensing model through other parts of the world, and we're getting quite strong interest at the moment in Asia and the US. Sorry, I'm having a bit of trouble with the slides. We've spent a bit of time in the last few months trying to I guess cement our vision for the future growth of the company, and we've arrived at this, which is that essentially we just love bringing great ideas to life. I mean, that's the thing that drives us personally and as a commercial venture. But beyond that, we're quite selective about the things that we work on, and believe that ideas that address fundamental social needs are the ones that we want to be focusing on, and they need to do that in ecologically and economically sustainable fashion. So this project was very well suited to what we want to be working on. Next slide, please. we have a particular way of functioning within the company. So, and this is probably driven out of our backgrounds in research, but the need to understand problems at a fundamental level is very important to us. Building a team with the right skills and capabilities is the next step, and I guess we're working through that at the moment. We've grown from 4 people initially to, I think we're almost up to 15 now. We're working very hard on trying to create a working environment to foster that creativity and effectiveness, but without compromising important things like enjoying what you do. There's a culture there where we constantly challenge everything that we do, and that's done in a very sort of safe, inclusive way, so people feel as though that's something they can do. We are very open to diversity in all areas. And we believe that any success that we generate needs to be shared equally amongst not only the company, but then our market, the people who work for us, investors, and also in terms of our social responsibility. And that comes into that last point there. Next slide, please. The decision to focus on housing was one that evolved over a period of time. We'd established our first technology, which was the bend, and then rapidly realised that in order to promote that to the market, we actually had to take the next step, actually the next few steps, and demonstrate how best to build with that technology to maximise its benefits. And I'll explain the technology a little bit more in the following slides. But and so we focus our attention subsequently on these areas, so providing shelter and addressing Australia's housing affordability crisis. And we're now doing a lot of work in areas where people have been badly affected by bushfires. So we've got a significant project underway now to develop housing solutions for people who have been who are looking to rebuild after bushfires. Addressing climate change by reducing carbon footprint of future homes, and then reduction of waste in a number of ways. And then the scale-up strategies for maximising the social impact of our work revolve around 2 basic models. One is licensing technologies to third parties, and the other one's manufacturing in partnership with existing companies. Next slide, please. And our overall vision is a world where everyone has access to beautiful, functional, sustainable housing. And the Samaritan House project's up there in the centre. And Jim mentioned that started with a conversation that I had with him. Actually, it started before that. Bernard and Keith Fagg sat down over a coffee, and I think Keith still has the napkin where the initial sketches for this began. And this was where we started putting things together. So I think this is a great example, this project, of what happens in Geelong. Geelong is a unique place in that you have a lot of capabilities very closely positioned, and it enables us to bring these sorts of programs together quite rapidly. And James was a real driving force in making that happen. Next slide, please. This is our business model. So without going into detail, what I'm trying to convey here is that we specialise in taking very raw ideas all the way through from a fundamental concept all the way through to something which is commercially viable. So in that sense, we're sort of bridging the divide between universities and industry in a way. So we're actually proving that these ideas are commercially viable and partnering with people through that initial commercialisation phase to ensure that they're successful. And this is an important part of the model. And you can see the various logos there. We have a strong emphasis on partnerships all the way through that. So we're partnering with Deakin and potentially other universities in different areas early on in the process. And then we start to work with local companies who have specific areas of expertise that are relevant to that technology. And then as we move through, we start engaging with companies that may take the idea on and work with us to commercialise it. And you'll see the BlueScope Steel logo there. So that's our first foray into this. And all the way through this process, we're I guess, collaborating with the market, trying to understand as much as we possibly can and feeding those ideas back in again. So our pipeline of ideas is growing all the time rather than diminishing, but the number that we're working on at any one time is also growing all the time. Next slide, please. So this is the initial technology. So we've invented a process for bending corrugated iron at sharp angles. The background story here is an interesting one, and I won't go into huge detail, but the person who developed the science behind this idea is a guy called John Duncan, who lives in New Zealand, but he was a long-time mentor of Matthias Weiss and myself when we did our PhDs and while we were working at Deakin. And we worked with him over a number of years to sort of understand how this could potentially be put into a technology which had some utility, and settled on this. And so, in a very short space of time, actually, once we decided to work seriously on this, we managed to develop the tooling and develop a prototype and get this all working. And so the venture really has evolved quite quickly from this early stage. On the left-hand side, that's the first bit we ever did, and on the right-hand side is a small building that was designed in collaboration with Lana, who's also a Deakin graduate, and that's now sitting out on a property in near Queenscliff, looking out over the heads. Next slide, please. The functional benefits of the technology are essentially the fact that it eliminates gaps in the structure, so that has benefits for fire resistance and sealing up the building envelope. So anything to do with sealing out moisture or airflow or sites for ingress of dirt and animals. It also provides a structural join, so whereas you typically have to put a flashing over a connection between two adjacent walls or two panels of a roof, you can now wrap the sheet around that join to create a structural connection, and all of these things provide benefits in terms of energy efficiency. So the work we've done now with Samaritan House is all about showcasing how some of these things are possible in a real structure. Next slide, please. And this is my final slide. So this just highlights one of the benefits of having the close association with Deakin. So one of the questions that arose when we started this was, are you damaging the material, and will it degrade any faster than the base material did? So within literally a week of having completed our first trials, we were able to look at things under a microscope and also complete some accelerated weathering tests to just confirm that the technology was not damaging anything in a way which would reduce its life. And so this was one of the fundamental things that BlueScope was interested in when they took the technology on, the fact that we could prove the viability of it, not only commercially but functionally. And I'd also like to thank everybody involved in this project. It really has been an immensely rewarding experience, and also been a great stepping stone for FormFlow as a company, and for future collaboration. So through the work that we've done here, James and I are speaking about what we do this year and next year for ongoing projects. We're continuing to work with Samaritan House, and we're looking to the future for other ways to collaborate and I guess use this as a stepping stone into new things in the future. So thank you very much.
Thank you very much, Matt. Great presentation, telling us a lot about FormFlow and the material strategies that you have. Our next speaker will be Brian Sherwell. Brian is a super client, and I not only mean that from a personal standpoint and being a super person, but also super knowledgeable. He comes from a background where he was able to give students pretty much real-time information about making decisions, which is always good coming from a client. Brian Sherwell is a member of the Samaritan House Board and Building Committee Chair. He assists the board with building-related matters and has taken the role to represent the board with the project management of the Independent Living Unit project. Brian has 8 years project management experience with Australia Post Buildings and Properties Division, followed by over 34 years in building control. Brian retired as founding director of BSA Building Surveyors, previously Brian Sherwell and Associates, which continues as the largest building surveyor practice in regional Victoria. Brian, please tell us a little bit more about Samaritan House in relation to the project.
Thanks, James. Yeah, very grateful to be here this afternoon to represent Samaritan House and at the webinar, just to convey to the listeners just exactly what we as Samaritan House people are about, our goals, and also our role in the prefab project, and also the endeavours to actually assist the homeless men in Geelong region, and hopefully by the end of this, so our role will be a little bit more understood. Next slide, please. Samaritan House is a not-for-profit organisation formed to make a difference in the lives of homeless men in the Geelong region. We exist through the kindness and generosity of the Geelong community, individuals, businesses and government and charitable organisations, both in a financial way and through volunteering. Samaritan House has a vision to provide crisis accommodation and work alongside our guests to strive for a transition to a better and stable future. The objective of our independent living unit project is to provide homeless men with an opportunity to experience self-sufficiency via longer-term affordable renting and supported accommodation, with the aim of transitioning to their own independent public or private housing, thus breaking the homeless cycle. Next slide, please. Samaritan House was formed in 2012 as a community-driven response to a growing problem of homelessness in Geelong. Faced with a severe shortage of short-term crisis accommodation, a group of concerned Geelong citizens came together to meet the challenge. A 1-acre property at Coppards Road, Moolap was purchased with the generous support of Geelong businessmen and the Geelong community. This site included a 4-bedroom dwelling that was used to accommodate the first of our homeless men as guests. I say as guests because that's exactly what they are. They're guests to the board from the point of view of their plight, and we treat them as guests, and the whole program revolves around that particular issue. Next slide, please. In 2015, the program was expanded through the construction of a 9-bed crisis accommodation building, and with the generous support of Geelong business community, and in particular our patron Lino Bisnella. You can see that 9-bed crisis accommodation slide at the house at the side there, and the original building being the Kevin Dillon College, the brick veneer building down the other side there. And we were fortunate that this is presents on a property that's quite substantial, being an acre, which has a large area at the rear there to provide the opportunities that we now are embarking on. Next slide, please. The Samaritan House Geelong community includes a 13-board member, all volunteers with a wide range of skills and backgrounds, which help promote the program. We arrange funding and give support to the program management. As our program expanded, we moved from a board-appointed manager with volunteer support to a contract with Salvo Connect Barwon, also supported by volunteers. Their experience in case management and entry point vetting provided a more focused approach to guest selection and support. The success of Samaritan House Geelong is reliant upon a magnificent group of volunteers who support Salvo Connect, providing meals, overnight care, cleaning, laundering, ground maintenance and transport. Beyond this individual support, we're also generously supported by Geelong community groups such as Rotary clubs, schools, and by the Geelong businesses. Wherever the need arises, these groups don't hesitate to give the board and therefore our guests a hand up. Next slide, please. Since 2012, Samaritan House Geelong has provided accommodation for in excess of 600 men. The program has seen 50% of the participants transitioning to permanent accommodation. Our two existing programs include a 9-bed crisis accommodation. Guests are accommodated from 5 p.m. to 8 a.m. the next morning. They are transported to and from the Geelong CBD, where they can avail of day outreach programs such as Lazarus House. The men have the surety of knowing that they can return to the accommodation for the tenure of their contract with the comfort of a bed, hot shower, an evening meal, as well as being supported by trained case managers and volunteers. The original 4-bed dwelling is now used as a share house where the men attend 24/7 for periods of 3 to 6 months. They are responsible for their own meals, upkeep of the house, and they're supported also by our case managers. Next slide, please. With transitioning to independent living, the focus of the program moving forward, the board determined the need for independent living units. Given planning permit requirements and our existing guest numbers, we embarked on a 7-unit project. Upon hearing about our intended projects, we were approached by FormFlow. They demonstrated their unique material technology and prefabrication module methodology. Knowing of the Prefab 21 project, FormFlow introduced the potential collaboration with Deakin University School of Architecture and Built Environment for the design work. Given the design and the viability of a real meaningful project, grant submissions were successful with the state government and City of Greater Geelong, with further support from family benefactors and Geelong businesses. The collaboration with FormFlow and Deakin greatly assisted in the success of some of these grants. Along with Deakin University, a partnership with the Gordon Institute of TAFE for some on-site assistance provided additional project benefit with the return benefit of a real experience for the students of both institutions. Next slide, please. As with all projects, there are challenges, constraints and specific needs that determine design and affect construction. Some of these included the site presenting with localised flooding problems, thus requiring elevated floors. The limited clearance between the existing buildings of 2.9 metres, as you can see from one of the slides previous. They were very tight and they presented a construction challenge and highlighted the importance for modular construction. Passive solar orientation and sound sustainability and energy efficiency were also important design elements. The design needed separate bedroom and living spaces rather than a studio model to provide the guests with a better living experience for them and their visitors. And the use of low maintenance and robust materials was very important to the project. We were keen for a design that invoked the element of pride and to enable our guests to feel wanted and to actually take care of their environment. One unit needed to be fully accessible to provide opportunities for men with disabilities to be included in our program. Next slide, please. The students visited the site to appreciate the conditions and to inform their master planning. Their renders and pictorial work assisted the board to appreciate the outcomes and also importantly supported applications for grants and funds. We were very much indebted to the work that was done by the students on the basis that some of these grants I think got over the line because of the presentation that was able to be put to them. Next slide, please. As James has discussed, the unit syllabus and workshop process from the Deakin University's perspective, I'd like to actually present our perspective from a client perspective. I'm very happy to say that it was a very rewarding process to engage with the students and staff. We were impressed with the access to the students had to Deakin staff who brought to the process a diverse range of design, sustainability, construction and project management knowledge. There was a clear and organised approach to the outcomes expected of the students with their goals and the project objectives well addressed in their unit syllabus. The workshops were conducted to allow the students to understand the brief, be informed by the diverse range of contributors, including external interest groups, as mentioned by James earlier, groups like Geelong Sustainability and Richard's area They were very helpful to the process to allow the students to appreciate all of the components that go into good design. And it also helped to develop the syllabus or the workshops helped to develop their design concepts, participate in a team environment, and to experience an encouraging critique of their work. And I think that was very important. They were very proud of their work, and obviously a lot of them were, hopefully their designs were going to get over the line, but as I say, it was a very good collaborative approach to actually critique those works. The students were given the opportunities to participate in a process that closely mirrored a real project design develop process, which in fact it was. Consequently, not only is Samaritan House Geelong a major beneficiary of this wonderful process, but more importantly, the homeless men of Geelong and our community will be looking forward to housing those guests in our thoughtful design and well-crafted units. Thank you.
Hello, sorry, had a moment there working with my mouse. Thank you very much, Brian. Great presentation. Thank you for giving us your perspective on the project. Our next presenter is Professor Richard Tucker, who has published widely on sustainable and universal design, urban design, and relationships between health, accessibility, and inclusivity in built environment design. He is a director of the Home Research Hub, an interdisciplinary group of 30 Deakin researchers that works with local communities to co-design solutions to complex problems of affordable housing, homelessness, and social inclusion. Richard is a project leader of the Micro Village project, which explores the viability of affordable houses for those with limited funds and a desire for modestly sized homes that minimize consumption of building materials, land, and energy, and which integrate and link with the community in meaningful ways. Home is addressing this by testing the viability of affordable tiny house alternatives, such as our Prefab 21 prototype. Richard, thank you. Thank you for coming, and please take it away with your presentation.
Thanks, James. I'll start by just telling you a little bit more about the Home Research Hub. Our team is spread across all over Deakin. We've got experts in industrial design, engineering, architecture, health, homelessness, disability, accessibility, universal design, indigenous knowledge exchange, human geography, placemaking, anthropology, systems thinking, community engagement, the arts, policy, law, property, and economics. And what is the left? These are all fields that are connected when we consider housing issues. Prior to the formation of Home, these researchers had largely been working in isolation on these problems. Next slide. Our vision is a simple one: homes that are safe, adaptable for all stages of life, matching our needs, and so sustainable collectively and individually, where we can strengthen neighbourly relationships across difference, connected to services, facilities, and the wider community. In other words, put simply, homes for life: home we can afford, a home where we know our neighbours, a home that's connected, and a home for all. Next slide. One of our current research projects is the Geelong Microvillage. As James says, this aims to critically analyse the viability of an affordable small houses model to accommodate those with limited income and wealth. It was funded by the Lord Mayor's Charitable Foundation and by Geelong Community Foundation. The project ran in parallel and is symbiotic with the Prefab 21 project, although the stakeholders are different. Next slide. The wider context of the project is the growing global tiny house movement, a model with three primary attractions: decreased costs, a simplified lifestyle with less environmental impact, and increased freedom. Sorry, I just had a reminder come up on my computer that completely threw me off there. These attractions were well known to a group of retirees who had teamed up with Geelong Sustainability to challenge regulatory barriers to smaller homes in Victoria. They first came to us for help to design a tiny home. We said, we'd like to work with you from a more critical standpoint to examine some of the problems with tiny homes that undermine their wider viability, such as, next slide. Unlike a house, but like a car or a caravan, tiny homes are a depreciating asset when on wheels, a problem that could be addressed by a combination of better design and performance, for instance, through prefabrication, and by putting them on foundations if the planning system allowed it. Next slide. Also, apartments offer a more appropriate model for high-density living. Next. Tiny homes are not designed for aging in place or for people with disability. Next slide. They're also associated with a lack of urban and social integration between units and the wider context. In other words, the need for models designed for better intra and inter-community integration. Next slide. A further problem is that the thermal performance of homes on wheels has been poor and integration with passive and active systems limited. All this means that tiny homes, especially on wheels, have an image problem, and the majority of suburban homeowners would rather not see a cluster of them in their backyards. Next slide. So the project has two overarching aims: to test the viability of affordable tiny house alternatives in relation to three key issues: regulatory barriers, such as statewide planning schemes and local council regulations; environmental design performance, which is the integration with passive and active energy systems; and financial modelling, upfront, ongoing, and exit costs for residents, compared with available alternatives, and to develop a model of best practice for a socially integrated cluster of small affordable homes suitable for those in Geelong with limited wealth, low income, and or a desire for modestly sized homes. Next slide. We're using three types of research: an evidence review, which includes a detailed analysis of the regulatory context; primary data collection from a wide range of stakeholders using a systems thinking and community knowledge exchange platform known as Sticky; and research by design via an evaluation of work contributed by our students. Next slide. Here's a Sticky systems map. This is a causal loop diagram that provides a holistic picture of the context, in this case, of barriers to accessibility and inclusion in Geelong from an earlier project. For Microvillage, we're looking at identifying the obstacles to building clusters of homes that are between 20 and 40 meters squared. Next slide. Two student design studios explored design solutions. The first was James's Prefab 21 studio with FormFlow that looked at the design of the unit, and the second was Stuart Seaton's Earthscape studio, which looked at the village design. Next slide. Our primary aim is to provide an evidence base for policy change and to determine if such policy change would have benefits. But of course, we're working with a group who simply want to build now and live together as a community in a cluster of well-designed tiny homes that are financially viable and resource efficient. We'd like that to happen too, because then we can extend the research to evaluate the model, to see if it works for them and how it might be improved. But as researchers, we must remain neutral and objective, and we can't help them find the land to build the microvillage on, an obstacle that remains unresolved. And of course, we're having to reappraise how we talk to people, especially in groups, a problem impacting a great deal of Deakin research under COVID-19. Next slide. How can you take part in the research? The easiest way, if you're a resident in Geelong, is to tell us what you think about the idea of living in a village of prefab 21s. What you prepared to pay for that, and how can the design be improved? We'll send you a survey link after the presentation. Next slide. And to end, here's just a note of a couple of Home's recently completed projects so that you get a better idea of what we do. The first, for the Department of Health and Human Services, informed a collective plan of action supported by a wide variety of community stakeholders to enable Geelong to be accessed, understood, and used to the greatest extent possible by all people. The second, for the Department of Environment, Water, Land and Planning, and the Office for the Victorian Government Architect, provided recommendations for how the Victorian planning scheme can better support child and family-friendly apartment buildings. The project informs changes to the Victoria Planning Provision's Better Apartment Design Standards and informed the brief for the Future Homes International Design Competition. Final slide. Previous slide. If you'd like to partner with Home on research, simply email me or reach us via our website. Simply do a Google search on the Deakin Home Research Hub. Thank you.
Thank you very much, Richard. Really appreciate that overview of what Home is doing and will do in the future. I think it's really important that we are engaged at the many different scales of providing homes, everything from prefabricated units like we've presented today, all the way up through understanding how neighborhoods can be affected by the research that you're doing through the Home Research Hub. So thank you very much. We have time for some questions now. I think we'll run probably about 10 minutes worth of questions. And if my panelists are able to open their Q&A on their window, they might get a preview of some of the questions. I'll be directing a couple of the questions to a few people now, and we'll move forwards from here. One question I think that will involve Matt, because we've talked about this as a research, a future question for research with the work that you're doing. A question from Eric Watson. Why didn't you use timber rather than steel frames?
Yes, that's a good question. There's a number of reasons. Probably the main one is to do with ease of prefabrication and the use of techniques for mass production of housing. So a lot of what we're doing is very focused on, I guess, emulating some of the things that are done in the vehicle manufacturing sector, and so there are more opportunities for speeding up and making more repeatable production using steel frames. So that's one reason. It also has some benefits as far as moving prefabricated sections of buildings around, being able to lift and drop things into position and maintain a stable unit for transport is somewhat easier. And I guess we're working through the sustainability aspect of all of this as well. So timber's always generally touted as a renewable resource. And steel not necessarily, but the steel that we're using is about 20% recycled content and is also 100% recyclable. And in order to do plantation timber, you need to get rid of some native forest in order to do that. So I think there are some open questions there, but we don't know the answers to them, and we're exploring those. So I hope that's at least part of an answer.
Thank you, Matt. Our next question actually builds on one of the points that Matt just brought up, and maybe both Brian and Matt can take on this question. From Andrew On, how transportable are these housing units in the non-assembled state? I.e., was any consideration given to how many trucks or semi-trailers are required to transport the components of a complete unit? And maybe, Brian, you can give us some insight onto the limitations of the transportation of the units onto the Samaritan House site in particular.
Yeah, sure. As we have the two existing buildings providing the programs that we have, and we're going to be very mindful of that process, with our programs needing to be kept running during the process of getting these module buildings onto site. It was very important to actually acknowledge the constraints that we have. As I mentioned in my presentation, we have a a building clearance of 2.9 metres between the two existing buildings, and that was going to represent a very real problem. I mean, we could have gone with a complete on-site construction process, but again, that's a very noisy process. It's a very interruptive process with construction of the vehicle going down between the two buildings. So we saw the process of the prefabrication working, and particularly with the module design, and with giving Matt and FormFlow the constraints of 2.9 metres, we needed to have something that was going to work on a modular fashion, that was going to be able to pass through the two buildings on the driveways. And the whole process of being able to prefab and bring them on site in units was going to, as I say, protect the existing programs. So Matt, you might like to talk about the transport side of things.
Yeah, sure. So you can actually put the 4 modules all on the back of a semi and transport them in one piece. So the fact that it was broken down into such small units was explained by Brian there. Our building system evolution from what we're doing with Samaritan House is purely based around transportable units. So it's 3.5 metres wide, 10 metres long, and no more than 3.8 metres high, and that's essentially the maximum size that you can put on the back of a truck without needing to also have a pilot vehicle. So from an efficiency point of view, that's a cost-efficient way of transporting a volumetric prefabricated structure. There, obviously you can do other things when you panelise them. But so yes, to answer the question, there certainly was consideration given, but it was quite specific to this site, the module sizes that we arrived at.
Thank you. Here's a question maybe that Richard can chime in as well with a big overview. And then Matt, maybe we'll actually need to talk about our particular strategy for this unit. Question from Tony Arnell. Sustainability and energy efficiency credentials are hugely important with this type of housing. Great job. Currently, there is a global interest in passive house standards for energy efficiency. Would this be possible for this design?
Actually, James, I think this is probably a question that Matt would be better qualified, because it's a question that I've had as well. I know this is 6-star rated. I'm just wondering, I've also wondered, Matt, whether the technology would allow for a thicker wall construction, greater insulation. I agree with Tony. It's if we could create a cost-effective model that was at a much higher performance level, we could probably push the case for the model much more strongly. But Matt, I think you can probably best answer the construction challenges around that.
Yeah, so there are a number of competing demands there. So yes, theoretically, there's no reason. In fact, the bend technology that we've developed should assist greatly in achieving passive house airtightness standards, because it does give you a completely sealed joint at the corner. So it will provide a significant benefit there over a conventional steel-clad building. One of the other challenges we have, though, is as soon as you make buildings airtight, you can create condensation issues. So there's quite a bit of work going on at the moment at University of Wollongong to understand the performance of steel-clad houses and houses with other types of cladding as well, to maximise the thermal comfort inside the building, which is effectively what passive house is intending to do, and at the same time not create mould problems because you get condensation build up in the walls. And there's some really encouraging results there. So on the one hand, we could definitely create a house that would meet passive house standards. Whether that's the most effective way of creating a building which provides you with the minimal heating and cooling loads and maximal internal comfort is still, I guess, up for debate.
Thank you. We seem to be getting a lot of technical questions, Matt. So here's one that maybe follows up a little bit on the passive house strategy for future modules. Charles Drummond asks, can you achieve a BAL rating of 40? And is it possible to use this technology in flame zones?
Yeah, so we're working on exactly this problem at the moment with an architect called Ian Weir, who's done some quite well-known buildings in bushfire-prone areas over the last 25 years. And we're achieving designs, we're creating designs that will achieve an FZ rating, so a flame zone rating, and our intention is to try and find ways through prefabrication techniques to bring the cost of a flame zone compliant house down to something manageable. So one of the big issues in the bushfire prone areas, or in the areas that have been affected by bushfires, is that people either weren't insured or had insufficient insurance to be able to rebuild to that level of construction. So we're trying to find solutions to that, and we're making really good progress. We've got a number of projects in New South Wales at the moment, and we've been working with the Business Council on some sort of commercial retail as well as residential stuff. So the answer is yes, you can certainly do that, and that's one of the benefits of the all steel construction approach as well, because you've got everything's non-flammable.
I also add, Jim, from a retired building surveyor's perspective, I mean, the material innovation that FormFlow have been able to introduce with that seamless join at the corner is such a fantastic innovation for bushfire prone construction. So whether it be for flame zone, it's certainly going to go right up the tree to lower Bell ratings that can actually it can greatly assist the ember protection or the ember attack protection and other aspects of bushfire prone design. So it's a fantastic product from that point of view.
Thank you both. One question for Richard that I think is a broad question that you're dealing with in general in your research with the home group, from Matthew Secatore. Banks don't usually provide funding for dwellings under 50 square meters. Since most homes are people's main financial asset, how would a microvillage of homes under those lending criterias benefit from these purchases?
It's actually a great question, and the short answer is it wouldn't. Strata title management's expensive, lenders aren't keen to lend, and currently there are insurmountable financial obstacles. We've had a focus group with finances, but no solutions were offered. The next stage of the project is to have a systems thinking workshop where we're going to meet with stakeholders from all across the issues, including those who want to live, those who might want to finance, planners, all the people concerned with the obstacles that at present mean that it's impossible to build a cluster of small homes, apart from with obviously Brian's project, where we've been able to kind of get around those obstacles, but currently it's not a viable model. And the next stage of the project is to try and find out how we might be able to collectively overcome some of those obstacles.
Thank you, Richard. Here's one actually that's maybe for all panelists. What are the current regulations around tiny houses? These houses are on wheels, but who owns the land, etc.? And maybe connected to that, particularly in Samaritan House case, how did you approach the issue of creating a microvillage with the particular zoning for that council area?
So
if I could
go on, Richard, sorry.
Yeah, I was just going to address the issue with tiny houses on wheels. The reason why tiny houses have to date been on wheels is to get round planning regulations. And so when they're on wheels, nobody owns the land and they tend to be in people's back gardens. What we're trying to do is to find a way of building tiny houses which aren't on wheels. So they're on foundations, they're better designed, they have a much better performance thermally if they're on a slab. So the fact that they're on wheels is just to get around planning regulations, and we're trying to provide a model to persuade the policymakers that that if people want to live in small homes, then why shouldn't they?
There's also an issue with the dwellings that are on wheels that come under a different lot of legislation from the point of view of building regulations, and they're actually exempt from building regulations, being unregistered mobile dwellings. They're governed by the health legislation rather than building regulations and the Building Act. So therefore, they do present sort of some challenges from the point of view of the construction thereof, and obviously it's something that probably needs to be looked at from the legislators as well.
Matt, just to follow up on that, in your business now that you're dealing with a lot of queries about creating these kinds of modular structures and tiny homes for people, how are you engaging the issue of making these structures either permanent on the landscape or dealing with them being portable?
Well, it's very dependent on the local authority and the local planning rules. So, I mean, in New South Wales, for instance, they have specific rules around relocatable dwellings that are quite different to the ones in Victoria. So we're just working with the through the local agencies to try and understand what is and isn't possible, and then making sure we stick within the rules.
Very good. And now here's one last sensitive question. I think that all panelists can chip in. Maybe Richard, as a big overview, you can talk about the costing of these kinds of things. But we have a number of questions about how much did this cost, either in a cost per square foot basis or, cost per square meter, or an overall cost for this particular unit for Samaritan House. But maybe Richard, you can give us an overview, just a general kind of ballpark idea about tiny houses and the variety of tiny houses that are available in a costing strategy.
Well, it's possible to build a tiny house yourself, probably for about $30,000 or $40,000. There's also a lot of options out there on the market with I guess small builders actually producing prefabricated tiny houses, and they cost between, depending on the area, between I think around about $70,000 and $100,000. And as far as I understand, Matt, you might correct me here, but I think the Prefab 21 cost $110,000. There's also a model of a project which was a collaboration between Launch Housing, Harris Transportables, and it wasn't TAC, it was the Vic Roads. This was a project in Footscray. They built 9 units there. I think they were around about $100,000 per unit. But you need to add about $50,000 per unit in that case for infrastructure and civil works. So at the moment, they're not cheap.
No, I think that's right, and I think we believe that exploring the possibilities for prefabrication and I guess serial manufacture of sections is one way of trying to pull the cost down. So we're already seeing that makes a significant difference.
Great, thank you very much. I think we've reached the end of our time now. We've run a little bit over time, and I'd like to thank all of our panelists and answering those questions on the fly. I appreciate that very much. And now maybe I'll turn it over so that Sam can actually wrap up the session. Thank you.
Wonderful. Thank you so much for that, James. And thank you to all our panelists and to our audience for joining and for that wonderful conversation. I would just like to mention too that for those people whose questions we didn't get to, we might send some of those through to our panelists and see if we can get some insights, and then send the answers through to you via email as well. So just running through a few things from our alumni relations point of view, just wanting to let you know that for our graduates, we'd love to stay connected with you. We'd love for you to update your details, contact details with us. You can do so by emailing deakinalumni@deakin.edu.au or visiting the website displayed on your screen here. You can also follow us on our social media channels, and I'd encourage those non-graduates in the audience to do that as well, because we have lots of great online events at the moment coming up like this one, so we'd love to keep in touch with you. For our alumni and the immediate families of alumni, just letting you know you're eligible for 15% off postgraduate course fees. And there are some T's and C's there, so please check out the website and you can email us for more details as well. To view past webinars like this one, you can head to our YouTube page or the website displayed on the screen here. Also just flagging that attendees will receive an email in the coming days with a recording link to this, so you can review the presentation as well. Thank you very much. Any feedback, please do feel free to send that through to deaconalumni@deakin.edu.au. Thanks once again to all our panelists and attendees, and I hope you enjoy the rest of your day.